go over what he has to do this trick for you guys. Well, it's not a trick, it's a stunt. Do we have any guitar players in the audience? I know there was one here earlier. Yeah. So it's not the easiest instrument in the world. It gets way harder when you have to play the guitar while wearing a chainmail glove, a bicycle helmet, and getting zapped in the face with over 500,000 volts of electricity. So I think he deserves another round of applause. So how many people here have heard of ArcAttack before?
Can I take it off?
Got a few? How many of you know us from YouTube?
How come?
Couple. How many of you know us from America's Got Talent? Not bad. And how many of you, this is the most important question, have no idea what's going on right now? We are a crazy mad scientist / rock group, and we tour around the country with these machines behind me called Tesla coils that we've engineered in such a way that they play music. So all the tones that you were hearing were actually coming from the spark itself. But we'll get into that in a little bit. First, I want to hand the mic off to our lead safety technician, Sam. Everyone say hi, Sam.
Hi, Sam.
Sam's going to teach you guys a little bit about high voltage and capacitors.
Hi there, everybody. As John said, I take care of the safety here at ArcAttack. You'll see me back here. I play the big red button. And I want to talk to you a little bit about electricity, magnetism, and capacitors. But before I get started with all of that, who wants to see an explosion? Because everybody likes explosions, right? That's it for explosions? Everybody likes explosions, right? Okay guys, this will be loud, so I recommend that you plug your ears, and I will count down from 3 to 1, so I don't start.
Plug your ears. No, plug your ears with your hands. Plug your ears
Alright,
with your hands.
in 3, 2, 1. So what you just saw there was a piece of aluminum foil being vaporized by electricity. I put around 10,000 amps of current through that piece of aluminum foil, and it just could not handle it. But how I did that is I used a device called a capacitor. And I'm not sure if you're familiar with a capacitor, but a capacitor is kind of like a battery in that you can actually store electrical charge in it. But unlike a battery, we can discharge all of that energy in an instant. And that allows me to do some pretty neat demonstrations. So now I'm going to talk about magnets. Hopefully you've all played with magnets at some point in time in your life, because magnets are pretty cool. You'll notice that magnets stick to some things like steel and iron, and refrigerators, of course. But, you know, not every